Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to be talking about the right angle theorem. Now, I want to make something clear right from the get-go. This is not to be confused with the right angle congruency theorem. The right angle congruency theorem states that if two angles are right angles, then they are congruent. Now, I know that we've been saying in our proofs before right angle theorem. I'm going to take the blame on that. That's going to be my fault. We should have been saying right angle congruency theorem. Or you could just say right angles are congruent. So again, this is not to be confused with the right angle congruency theorem. The right angle congruency theorem states that if two angles are right angles, then they are congruent. Okay? This is completely different. The right angle theorem states the following, gentlemen. If two angles are both supplementary and congruent, then they are right angles. And we kind of talked about this yesterday. I don't know if you remember. And I said, oh, we're going to see this tomorrow. And let's visualize the above theorem. Okay? I have this angle 1 and angle 2. The good news, you will no longer have to say that that is a supplementary, that those angles are supplementary. We've already assumed straight lines. So since you can assume straight lines, we can assume that if two angles or three angles or five angles lie on that line, they are going to be supplementary. Okay? But what this is saying, this right angle theorem, is stating the following. We know that angle 1 and angle 2 are supplementary. Awesome. So that means that if angle 1 and angle 2 are supplementary, using the addition property, angle 1 plus angle 2 equals 180 degrees. They also say if angle 1 is congruent to angle 2, then angle 1 and 2 must equal 90 degrees each. Think about it. If we know that angle 1 and 2 are supplementary and they're congruent, well, what other two congruent angles can give you a sum of 180? Is there none? If they're supplementary, that means that 1 plus 2 is 180. If they're both congruent, let's look at it algebraically. Let's say that's angle x. But if angle 1 is congruent to angle 2, then that means 2 can be called x. So that means 2x equals 180. And if 2x equals 180, divided by 2 to both sides, x has to be 90. So therefore, x is 90 degrees, which is angle 1, and x is 90 degrees, which is angle 2. Okay? So that is called the right angle theorem, not to be confused with the right angle congruency theorem. If two angles are both supplementary and congruent, then they are right angles. Powerful stuff here, believe it or not. Okay? The good news, that's the only theorem we have to learn today. So live it, learn it, and love it. Guys, I hope you realize that we've learned 20 some odd theorems already so far. There should be a lot of tools in your toolbox by now. You guys cannot forget these. That's what makes or breaks the proofs, you know, if you remember these theorems. So let's get to it. For example 1, gentlemen, AB is congruent to AC, BD is congruent to CD. I want to prove that AD is an altitude. All right, cool. Good stuff. Let's check it out. First things first, AB is congruent to AC. That's a given. Let's label it. AB is congruent to AC. Done. 2, BD is congruent to CD. That is a given. So BD is congruent to CD. Where do you think we would go from here, guys? Yes, sir. Very nice. AD is congruent to AD because of reflexive property. Fantastic. Very proud of you. Now where do you think we would go from here, guys? Yes, sir. triangle ABD is congruent to triangle ACD. Very good. Why? Side, side, side. Very good. Now that we have that, what can we prove? Think about what we're trying to prove. We're trying to prove that AD is altitude, so that means we're trying to prove that ADB is 90 and ADC, angle ADC is 90. So what would we say? Yes, sir. Excellent, son. Angle ADB is congruent to angle ADC because of CPCTC. That's exactly perfect. Awesomeness. Now we know that ADB is congruent to ADC. So what can we say now? Yes, sir, my brother. Phenomenal. Angle ADB and ADC are right angles. Why? Because of the right angle theorem. Now, some of you may say, whoa, whoa, whoa. You never proved they were supplementary. Remember what we said. We no longer have to prove that. We no longer have to state that. Now, if that makes more sense for you, do you think I'm going to mark it wrong if you tell me angle ADB and angle ADC are supplementary? No, I'm not going to mark that wrong. In fact, I'll be proud of you. Good for you. Some people have to see it step by step, and I'm not going to hurt you for giving extra information that is accurate and pertinent to the proof. But you no longer have to do that. You know by looking at this, okay, that line BC it's a line. So that's a line. That means that angle ADB and angle ADC are supplementary. We already proved that they were congruent. So if two angles are both congruent and supplementary, they are right angles. Okay? Because of the right angle theorem. So now, let's delete this little congruency symbol, and instead, let's add a right angle symbol. And now that those are right angles, how can we prove what we want to? Yes, sir. That's exactly right. AD is an altitude because definition of an altitude. An altitude is a segment, which we have a segment right here, which I'm going to highlight in blue, AD, which is perpendicular to the base, and it is perpendicular to the opposite side, or base. Does that make sense? Powerful stuff here, guys. Very useful. Very useful. What's up, my brother? Oh, yeah. You're going ahead of the next proof. Yeah, the next proof is pretty sweet. Yes, sir. Thank you very much, sir. It's easier that way. Yeah, good. Good, guys. I'm very proud of you. Now, yes, okay. That it's funny you say that, and that's the thing about geometry. A lot of times you guys will be like, wait a second, man. We could have really used this a long time ago. Yeah, there's going to be theorems that I'm going to show you now that you're going to say, oh my God, Mr. Morrow, hello, that would have really helped us out. But it's like you got to walk before you run kind of thing. I had to teach you first what right angles were. I had to teach you first, drill it into your heads, what supplementary angles were. We had to really drill in that supplements of congruent angles are congruent. You know, all of those little things had to be taught. But yes, I feel your pain. When you see a lot more powerful proofs, you're going to just really be upset. You're going to say, oh my God, Morrow, you wasted our time. Why didn't we just jump to chapter 5? So I feel you. But that's good. That makes me proud because that means that you're understanding the connections. So good job, man. Very proud of you. All right, boys. Now, this is a good proof. All right? Some of you are already solving it on your own, and that's awesome. They say that AB is congruent to AD. They say that BC is congruent to CD. And they want to prove that AC is the perpendicular bisector of BD. Whoa. Wait a second. We don't even know what a perpendicular bisector is. What do you think a perpendicular bisector is? What do you think that means? Yes, sir. Close. You're thinking. I'm proud of you. What do you think a perpendicular bisector is? No, but you're thinking. I'm proud of you. We'll give it one more shot. Very. That has to. Okay. Think about this, guys. It's perpendicular bisector. So we know that a medium, for example, bisects a segment, correct? And we know that an altitude creates a 90. It's perpendicular to that opposite segment, correct? Well, perpendicular bisector is something that basically cuts the segment into two congruent halves and creates a 90. Okay, that was very messy drawing. Let me do that again. So a perpendicular bisector, what we're trying to say is that AC not only bisects BD, but is perpendicular to BD. Does that help you understand what a perpendicular bisector does? It's a segment that bisects another segment and creates perpendicular angles to that segment. So it's literally a median and an altitude combined. And we're going to learn about perpendicular bisectors tomorrow. So this proof will be made a lot easier tomorrow. Okay? But that's what we're trying to prove. We're trying to prove that AC bisects BD and that AC is perpendicular to BD. Hence, I'm not being sarcastic, perpendicular bisector. It's both perpendicular to the segment and it bisects the segment. Thank you, guys. You guys are awesome, as always. Yes, sir. You're going to find out right now what we use. Sometimes you will use HL, but not really, because if you're trying to prove that it's a perpendicular bisector, you have to first prove that it's a right angle. So if you have to prove that it's a right angle, HL won't be in there, because HL you have to know that it's a right angle.
Yeah, like if I give you all this
If they give you that it's a perpendicular bisector in the given, then probably HL would be used there. Very good, son. Good thinking. Very, very proud of you. All right, boys, here we go. All right, number one. Okay, it's not, number one is not blue dot. Sorry about that. Number one, AB is congruent to AD. So let's label it. 2, BC is congruent to CD, given. So BC is congruent to CD, okay? Now think about what we have to prove. I'm going to go up to it again. Think about what we have to prove, okay? We're going to have to take a detour here. Where do you think we would go from here now? Yes, sir. You're on fire, buddy. AC is congruent to AC, reflexive property. Okay, that's my detour, guys. So AC is congruent to AC. So now I have these two triangles. And what do we know about these two triangles that I highlighted in blue here? They're absolutely congruent. Great job, my brothers. Triangle ABC is congruent to triangle ADC because of side, side, side. Okay? I'm going to give you another flash forward. This is what we're trying to prove. This is what we have so far. So think about this, guys. Think about this. Very good, son. Very good, man. I'm very proud of you. Angle BAC is congruent to angle DAC. I mean, really, really good job there. Why, my brother? You said BAE. BAE and BAC are the same angle. So it is what you said. Believe in yourself. And I'm still proud of you. All right. Why? 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 CBCDC. Very good. So now that we know that those angles are congruent, okay, think, what else can we do now? Yes, sir. Oh, dude, you were on fire. AE or, oh, boo to Mr. Morrow. It's AE is congruent to AE. Oh, I thought you had said the angle first. Okay, but first go angle, then go AE to AE. And it's going to get a little bit messy with the tick marks, so I'm going to mark this in red. AE is congruent to AE, okay?
Can we prove like the whole thing has congruence? Could we separate them so we're just trying to figure out?
You lost me.
So you know how triangle ABC,
ABC is congruent to ADC, yeah.
could you cut off that bottom part and just try and figure out?
That's exactly what we're doing.
No, I know, but instead of having it all bundled up, like separate that part of the triangle.
What you're saying is, can we now take this part here
Yeah.
and go ABD and work with ABD here and then add an AE? Absolutely, my brother. That works great. So that's congruent to that. That's congruent to that, and that's congruent to itself. Yes, that's phenomenal. Actually, well thought out, son. Well thought out. Okay. So AE is congruent to AE because of reflexive. So now what do we know about this these two isolated triangles that we just pulled out because of the very good suggestion from our boy? Yes, sir. No. You can't prove that BE is congruent to ED because you haven't proved the triangles yet congruent.
I have a question.
Okay?
I might have missed this, but why did you AE?
Okay, why did I prove AE only? Remember what we're looking for, my man. We're looking for this here. So this is only really dealing with this part of the triangle. All of this is useless now at this point. That's why I broke off this triangle into this guy right here. Not very neat, kind of messy, but this part here now is pretty useless to us. You with me? So now, back to where we are. What two triangles can we prove congruent at this point? Yes, sir. Very spectacular. Awesome. Or either way, you said AEB, I said ABE. That's fine as long as they correspond. Triangle ABE is congruent to triangle ADE. Why? Side angle side. That's spectacular. Yes, sir. Go for it. Yes. Yes. Now you can prove BE is congruent to ED because of CBCTC. All right, dude. Come on. Keep doing it. You're on fire. So now we prove that this guy is congruent to this guy, okay? Which, yeah, okay. Now what? Yes, sir. EC? No. Well, let's think about it, Don. Don't get me wrong. I'm not upset at all. Why would you want to work with EC? This part is gone already. We're trying to prove this here, that this is a perpendicular bisector. Don't we have the bisector part here already taken care of? So using CPCTC, what else can we prove that is congruent in both triangle BEA and DEA? Yes, sir. Yes. Very good, my brother. Well, first, AC bisects BD. Excuse me. Why? Definition of segment bisector. Okay? Because remember what we had just finished saying. We just proved the bisecting part, right? Kind of. We just proved that BE is congruent to ED, right? So remember what we're trying to prove. We're trying to prove that AC is a perpendicular bisector to BD. So we have to prove the bisector part. So AC is now for sure a bisector of BD. Why? Definition of segment bisector. Now we got to prove the altitude part. So what other part of these two triangles, triangle BEA and triangle DEA, can we prove congruent to help go down the altitude route? Yes, sir. Okay, this step 9, yeah, AC is a bisects BD, yeah.
Why do you need to say that?
Because we just think about what I just finished saying. In our proof, we have to prove that AC is a perpendicular bisector. So we have to prove that it's a bisector and that it's perpendicular. So by proving that BE is congruent to ED, now we know that AC bisects BD, definition of bisector. Now, again, I've been trying to get this last step for a while now, guys. What else can we prove that is congruent? Because of CPCTC, yes, sir. There it is. Angle AEB is congruent to angle AED. CPCTC. Now that we know that angle AEB is congruent to AED, you can look at it and you know they're supplementary. So what do we know about angle AEB now and AED? They're right angles because of the right angle theorem. Yes, sir. What's the next one then? AC is an altitude to BD or is perpendicular to BD. I would accept either one. Why? Definition of perpendicular lines. And now I have proven that AC bisects BD and that AC is perpendicular to BD. So now I can prove that AC is the perpendicular bisector of BD because of definition of perpendicular bisector. Now that's a proof. Now, please, any questions you want, even if I have to erase it and do it again. Sir, my brother. Yeah. Yeah, you have to remember that C is part of that, yes. Come again, my brother? Of course I can go back down. Sorry, son. But you have to prove here, and this is where some of you are a little confused, and I get it, man. You have to prove that AC bisects and is perpendicular. Now, some of you may say, but Mr. Morrow, didn't you already prove it by saying that BE is congruent to AD, to ED? Yeah, you proved that they're congruent, but what does that mean in relation to AC? That means now that AC, bam, bisects BD, and you have to state that. Some of you may say, Morrow, but didn't you prove that AEB and AED are right angles? Yes, I did. Absolutely. For sure. But now you have to state that because they're right angles, now AC is perpendicular to BD. And once you've proven that AC bisects and is perpendicular to AC, now you know it's a perpendicular bisector. Does that make sense, y'all? Promise? Thank you guys as always. You're amazing. Great class today. Great job. I'm very proud of you. Hope you learned a lot. Have a great day.